Okay, in this example 6, find the limit, and we'll look at why we can't use direct substitution. So we got the limit of this function as x approaches 1. So again, in order to use direct substitution, if we look at this function and we look at the domain, okay, the domain of this function, x can be any element between negative infinity to 1 and from 1 to positive infinity, right? The only value that x could not be would be 1, because 1 would make the denominator undefined. So that's the problem here. X is approaching 1, so we can't use direct substitution here. But what we can do, we can see if we can algebraically manipulate this function. We can see if we can simplify it. Okay? So let's look at x cubed minus 1. Okay? And I'm going to rewrite this as x cubed minus 1 cubed. That's the same thing, right? Do you see that this looks very similar to this? Where a would be equal to x and b would be equal to 1. So based off of that, I can plug it into this formula here. So I can make this 1, or x minus 1, x squared plus x plus 1 squared would be 1. Okay? This is known as the difference of cubes. This is the sum of cubes. Make sure that you memorize both of those formulas. So maybe pause the video, write that down. Okay, so I'm going to rewrite this as the limit, and I'm going to rewrite this as x minus 1 all over x squared plus x plus 1 all over x minus 1 as x approaches 1. So this original limit here equals this limit here. Okay, the numerator, I factored it. Now if you notice here, now this limit reduces, so now I have x squared plus x plus 1 as x approaches 1. Now if you look at this function, this is a quadratic function. The domain here is all reals. So now I can do direct substitution. Okay, so this would be equal to, let's see, f, so let's do this over here, f of 1 equals 1 squared plus 1 plus 1, which would be equal to 3. So this limit here is equal to 3. Okay?